So standard form, we don't know the highest degree is 5 or 6. I have no idea. So what I'm going to do is I'm going to use n, right? And then the powers decreasing by 1. n minus 1, n minus 2, all the way to 1 and 0. And the x to the power of 0 is 1, so I omitted it. It's just 1, right? So that is the general expression of polynomial. So when you say this in higher mathematics later in college or next year in calculus, this you can just be familiarized with this form of polynomials, and it can be anything. What's important in the general polynomial, an is not going to be 0. And then, because if coefficient is a 0, it's not, the term doesn't exist anymore, right? And n is a natural number. If n is not a natural number, for instance, if n is negative numbers, it becomes rational numbers. It becomes reciprocal functions, okay? So it's not polynomial anymore. Okay, do you understand? Is it okay? I don't think I really defined it before. Even function has even here. It's because n right here. Do you see the power n right here? The highest degree of your polynomial n, the power, is even numbers. Then what's going to happen is that the shape of your polynomial is going to generally look like that. I mean, of course, right here, there's a little bit like local up and downs. As we already learned in quartic polynomials, you have local maximums and local minimums. In the middle, there's a fluctuation. But generally, when x goes to infinity or negative infinity, you are going to go up, right? It's because a, the leading coefficient is positive numbers. Then, even numbers, but leading coefficient is negative numbers. What do you think it will happen to it? What do you think?
Can you say it again?
So case 2, the same condition. You have even.
It's gonna concave opposite way.
Very good. It's gonna concave down. It's gonna go downwards, upside down. And then there's a local, minimum and maximum. That's fine. But generally, it goes down. So what's gonna happen in even functions that if x goes to infinity, positive infinity, negative infinity, then you are going to go all together, y goes positive infinity. This is the case 1. Case 2 is if x goes to positive and negative infinity, y goes to negative infinity. So generally, it goes to same directions. It's either go up or down in even functions. However, so let me ask you, so the quartic function that we learned, quartic, is it even function or odd function? Even, right? Because it's either going up, quartic function right here. So quartic has 4, so it's always gonna go this way or that way, just in general. Let's talk about when your n is odd numbers. So typical example we had is cubic function, right? N is 1, 3, 5, and 7, dot, dot, dot. Okay, in this case, the shape of your polynomial was generally going up, and then there's a little bit of fluctuation and going up again. That was polynomial, cubic polynomials, right? And then when you had n is negative numbers, it changed its direction to negative. So it's developing, and then it's going down, something looking like that, right? So the shape is never fixed. It's always different and it fluctuates. But what's for sure is when x goes infinity, positive infinity, then y also goes positive infinity in this third case. If x goes negative infinity, y also goes negative infinity. That is case 3. Did I write down case 2 right here? Oh, yeah. So in case 4, you are going to have exactly opposite. So when x goes to infinity, in case 4, positive infinity, then y is opposite. Y goes negative infinity, right? And then when x goes negative infinity, y goes positive infinity. Right, so you have to understand the general behavior depending on the signs of your leading coefficient, and also if the powers Is even numbers or odd numbers? So let me ask you this question. You cubic polynomials we learned. Is it odd function or even function?
Odd.
Very good. So which one of functions, even or odd, passes at least one time across the x-axis? Which functions cross x-axis at least one time? Even or odd?